So if anyone would like to answer the question, you can always write on the chat section and I can unmute. Okay. Anybody? Not same. So why is it Camila? I can unmute you so that you can actually okay. So Camila, you can unmute so that you can explain why. Okay. All right. So it's okay. So actually the difference between crystallite size and also the particle size. So actually crystal size is actually the distance, the size of the crystal. Okay. But if particle size that you normally observe from FISM or TEM, or you measure it using particle size analyzer, is actually a combination of several crystallite size which made up several crystal structure, several crystal made up to be a particle. Okay, so make sure don't confuse. Okay, if you want to calculate the crystallite size, of course, from SRD, of course, it will not be the same as the value that you are getting in SEM, FISM, and also TEM. Okay, so if the crystallite size, okay, we are using Scherer equation to calculate. So so we will have the crystallite size here. K is the constant, the wavelength. Okay, lambda is the wavelength, and beta is the FWHM of the SRD peak, and theta is the peak angle. Okay, so for example, if we have this type of crystallite size, okay, where the D, okay, right, so the D spacing is normal, so it will have we could see the value of FWHM is getting lower, okay, because D is larger, so D is smaller. No, sorry. So D is larger, so the FWHM is smaller. Okay, so that's why in a normal crystalline material, we could see that the SRD peak is the peak of the SRD peak is very narrow and also sharp. Okay, all right. And if we have, okay, several crystallite, okay, with smaller size, okay, so the direction of each crystallite is not similar, it's not identical. Okay, so that's why in this case, okay, so the D is getting lower and the FWHM is getting higher. So that's why from this SRD peak, okay, we could see that the peak is getting, the width of the peak is getting bigger. Right? Okay, as compared to uh, the first scenario. For this scenario, if let's say we have some alloy metal, okay, where we have the crystal is properly aligned to each other, so that's why we are getting very narrow and sharp peaks. Okay, and then if we have even smaller even smaller particle size, a smaller crystallite size, okay, we are getting, so D is getting smaller, the beta, the FWHM of a peak is getting higher. So that's why mostly in nanoparticles, you will see the SRD pattern is getting the peak of your the SRD peaks of your sample is getting broader. So this is because of this reason. Okay. All right. So this is one is the crystallite size. So the peak width is actually very dependent on the crystallite size. And then the second one is on the strain. Okay. For example, right? So if there's no strain given at the sample, the peak will have at normal position. If let's say we compress the strain, okay, the peak will shifted to a higher position, which indicate because of the lattice size is getting this decrease. Okay, and the third one, if we expand the material, okay, the position, because D is inversely related towards the position, the theta, right? So if we expand the material, the strain, the lattice size is increased. And then if we have non-uniform strain, so we will have the peak is getting broader. So these two, strain and also the crystallite size, is really made an effect towards the peak width. Okay, so in not the summary lah, basically from SRD, you will get to know the phase identification. That means the crystal phase. You can also do the quantify using Ricbet analysis, and you will also get to calculate the value of crystallite size using the Schrödinger equation. So, okay. All right. So maybe later on, after this, after the sample preparation, I will teach you the basic of software analysis, how we can perform the phase identification using SRD software. For CAL, we are using high score software. Okay. So for sample preparation, I will invite Mr. Irwan, who is the PIC of SRD in CAL, to brief you on the sample preparation and the sample suitable sample for SRD. Yeah, Mr. Irwan?
Yes, okay.
Okay, all right.
Okay, Assalamualaikum. Good afternoon to all. So my name is Irwan. I'm the person in charge for the equipment, the SRD equipment, X-ray diffraction. Okay, so today I'm going to share to all of you about type of sample, sample preparation, and setting parameter for the SRD analysis. So if you can see the slide, it's the suitability sample for the SRD analysis. So normally we use powder sample. Powder sample is a very fine powder that we get it from grinding or crushing process that we use grinder or crusher. And then the second acceptance sample is the solid sample, but they have the maximum dimension. The maximum dimension are 10 mm length times 10 mm width and 10 mm height. If the sample are bigger than the maximum size, we cannot perform it in our SRD because of the sample holder cannot hold the sample. And for the coarse powder and irregular solid, it's not suitable because it does not imitate a flat surface. Okay, so for the powder sample, we use a sample holder and also backloading accessory. Okay, so firstly, we need we take the top part of the sample holder with the flat side and push the button and place it in the center. Then we take our sample and fill it into the top part of the sample holder using spatula. Okay, so after that, we take the bottom part of the sample holder and this space down and press it until it locks. Flip the whole block and press the button and lift it straight up. There you will get a nice and flat, smooth surface that level with the plate. That's for powder sample. The next slide, Shlo. Okay, this is for small amount sample, powder. Okay. So the accessories is sample holder. We use clip, aluminium liner, and zero background. Okay, first we need to assemble the sample holder. Take the top part of the sample holder and the zero background. Okay, put the shallow side of the zero background plate into the top sample holder. Then put the aluminum liner at the bottom of the zero background plate and lock it with a clip. Okay, take our sample and fill it at the center into zero background slit. Use a glass slit and press on the sample until it level with the sample holder. That is how we perform for a small amount of the sample. Okay, this is for solid sample. You use sample holder, the different one. Okay, firstly, put a small size of plasticine at the center of the in the sample holder. Its function is to stick your solid sample with the sample holder. Take the solid sample and put on the plasticine. Use a glass lid and slowly press the glass until it level with the sample holder. Okay, now it's ready to be tested. And for the thin film samples, we still use the same sample holder, but we have to add on zero background. Okay, still the same procedure. Put a small size of the plasticine at the center into the sample holder. Then take the zero background plate and stick to the plasticine with the flat surface is facing up. Use the glass lid to level the zero background with the sample holder. After that, put the thin film sample on the zero background plate. That is for sample preparation. 4 types of sample preparation. Okay, after we done the sample preparation, now we go to the sample holder arrangement. Alright, so we have 3 slots that mentioned by Puan Noor Sheila previously. Sample slot for the magazine. So one magazine can hold 15 sample. Sheila can play the video. Yeah. Now this one, the right. So one magazine can hold for 15 sample holder. Okay, the next video is to show the pneumatic collect the sample holder and transfer it to the sample stage. 15 slot of sample holder. Okay. Next slide, Sheila. Alright. After done the sample preparation and the sample arrangement, the last step is to enter the setting parameter. So our SRD are using data collector software to control and communicate with the equipment. So we need to determine the setting before conduct the test. There are 4 parameters that we need to provide, and it depends to the sample. First is the start angle. So the minimum angle is 2 degrees for our equipment. Then second one is the end angle. Our end angle, the larger, we can set until the maximum is 140 degrees. And the third one is the step size. So for the normal setting is 0.016 per step, but you can modify it and the minimum is 0.002. And the last one is the time per step. For the normal setting is 200 seconds per step. It also can modify until you get a good result. The graph there show an example for the raw result for SRD. I think that's all for me. Pass back to Puan Noor Sheila. Thank you.
Okay, so everyone clear how can we prepare the samples for powder samples, thin film, and also apa tadi the what type of sample that we have just now is solid sample. Okay, so after that, when after Encik Irwan run the SRD and you will get these peaks. So what do you want to do? So basically, for if you see the graph, you wouldn't know what is all about. So you can only see the peak, the position, and also the intensity. So that's why in SRD, you basically required to analyze this peak using a software, right? So I will, okay, all right. So I will teach you a quick one on the software analysis using, so everyone, can you see the software?
Not yet, not yet.
Not yet. Okay. So the software is actually, we install it at the software analysis room. Okay, at card. I share it again. Okay, all right. Okay, so the software is located, we install in PC in software analysis room, and you can open, the software name is High Score Plus. Okay, High Score Plus. So basically, you will receive from Encik Irwan two types of results, format. One is in Excel and another one is in SRDML. So for the SRDML format, you need to open it using HighScore Plus. So you just need to, as usual, file, open, and open the your results. Okay. So for this example, so what do you want to do is we actually have maybe 4 to 5 steps only. So to do the software and analysis, the first one is you just right click, just determine background. Okay, from here, okay, you just need to see the green line is actually touch each starting point of each peak here and also here. So you can adjust the value of bending factor. You can adjust the granularity. So make sure it is not like this. Okay. So it should be here because in the end, when we do the search match, when we do the face identification, okay, the software will calculate the value under graph. Remember the FWHM value, okay, and the search match process, the face identification will be depends on the position and also the FWHM value. Okay, so you can adjust these two. Okay, and then you just see overall all of the peaks is okay, right? Then you just click background and accept. Okay, so that one is the first step. The second step is right click. You just go to search peak. Okay, you click search peak, and so when you click search peak, it will came out all the how do you call that? The orange line at the upper side of the graph indicates the each peak of the your results. Okay, so when we zoom in, okay, so basically, so this is one peak. So don't bother because of the okay, you will have one peak and another one peak. So this is actually belongs to same plane. So this is we call it as K alpha 1 and this is K alpha 2. It is identical peak for each plane. So because of the different energy state. Okay. All right. So so after that, so you can just accept. So okay, if we see closely, you will have two type of graph. One is the red one and another one is the blue one. Okay, the red one is your original data, and the second one is the software generated graph. Okay, so basically, when we want to do the search, the face identification, we will need to make sure the software generated graph is really identical with the raw peaks that you obtain from SRD. Okay, because it's from previously position, width, and also the intensity really does have an effect towards your results. Okay, so that is why we need to do fitting. Okay, so you just click here, right click, execute fitting. You click default profile fit. Okay, and then you can see the graph is actually identical towards each other. Okay, for the fitting, you can actually do several times. Okay, if you see there's not really fit, then you can just do once again to make sure that everything is really identical. So that when we do the search match, it will really really what we call that represents to your actual sample. Okay. Then after that, if the peak is already the blue peak is already identical, okay, then you can perform search match, right? So you click search match and you click edit. Okay, you can choose whatever element. Yes, Mariam. Identical means the blue and red peaks is similar. Is getting similar in terms of the peak, in terms of the peak height, peak width, and peak intensity and peak width. Okay. All right. So so you need to choose. So you need to choose what are the elements available in your matrix sample. So what happened if you didn't know, this is unknown sample, you didn't know what are the elements available in your sample. So that's why actually you need to perform SRF analysis first. Okay, because from SRF you will get what are the elements available in your sample. Then after that, when you receive the SRF results, you can just always uh, uh, pick the elements available in your sample to perform the SRD analysis, because SRD analysis is not an equipment to analyze the uh, elemental analysis. It is just, the purpose is always to see the crystal structure of the material. Okay. So okay, don't please, because previously we don't have SRF. Our SRF is under maintenance. So that's why I understand some of the students, okay, and researcher basically use SRD to actually check on the composition. But actually, it's not the SRD is not really the function of the SRD is not really on the composition, but is more towards the crystal structure. Okay, so for this sample, so I know it has titanium oxide and also the copper oxide. So for this one, for first one, I choose titanium and oxygen. Okay, and then I close, search. Okay, I click OK. Right, then you can see the suggestion compound on the right hand side of the software. Okay, so it gives a rutile titanium oxide. Okay, when we click this one, okay, so basically so this is the selected pattern of rutile. So it match with this peak, this peak, this peak, this peak. Okay, we can actually scroll down. You just need to choose which one is the most match with the with your peaks, right? So normally we accept, if let's say 3 peaks identical, we can choose this one as the uh, pattern of your sample. So for example, like this one, maybe okay, it match with this one. Sorry, this peak, this peak. Okay, some of the peak is really matched with the rutile one. So we can just drag this compound as the accepted pattern. So when we see here, So we know that this peak, okay, this peak, okay, and this peak, this smaller peak is belong to titanium oxide. This peak belongs to titanium oxide, rutan. Okay, so rutan. So for those who are actually working with titanium oxides, you already know that titanium oxide has several crystal structure. Okay, rutan, and then another one is anatase. I forgot what is the another one. So, okay, and then we can search again. So we have anatase here. Okay, anatase here. Okay, it match with this peak. Okay, so I try to choose this one as well. Okay, then we can see, okay, this one belongs to rutan. This one belongs to anatase, right? So we have several peak which does not corresponds to any of them, rutal and anatase. For example, like this peak, okay, this peak. Okay, so we can choose another because we know we have copper. Okay, so we can select copper instead of titanium. Okay, just search match. All right, so you came out at this session, it came out all the candidates, right? So when we choose copper oxide, so then we know, so the remaining peaks is actually belongs to copper oxide. So from here, if you double click, you will know that the crystal structure of your material. So titanium oxide, you have tetragonal, and also for anatase, tetragonal, but maybe different planes and every different structure. And then copper oxide is in monoclinic structure crystal system. Okay, so basically all the information have in the in this database, the HKL value, the peak position. Okay, so you can actually save this one in PDF. So just click save as. Okay, just can save it in PDF format. So you can always refer the pattern that you choose. Okay, so this is all face identification. So and another step is actually you can click this one to show the quantification chart. So basically you will know that so okay, 75% is your sample belongs to copper oxide, and the remaining 90% is rutile, and another 6% is belongs to anatase. But this one, the is not really accurate because for the quantification we actually need to do the read analysis. Okay, so maybe read analysis we will not cover in this session. Maybe later on we will once again, okay, conduct the webinar on SRD. Maybe we will touch on um, the read analysis and also the Scherer equation, Scherer calculator. We can always use this software to calculate the crystallite size using Scherer calculator and also the read analysis. So so it's done. You already done the phase identification of this compound of your samples. Okay. All right. So maybe next one we will continue with this webinar on the ULab, how to book. Okay, how to book SRD in ULab. Okay. So if you want to book for SRD in ULab, you can always find it in CAL material. You go under request services. Okay, and then you choose SRD. Initiate request. So you just enter your name. Okay. So testing type is powder diffraction. So you just put in how many sample do you have? Let's say 5 sample and you need to click add selected services. So it will calculate the total amount that you need to be charged to your cost center, your grant cost center. And then you need to fill in the sample name. Okay, you can always drag if the name is similar and the sample type is similar. You can always drag. You can choose whether your sample is powder or solid. Okay, and sample description, maybe this one is sample name is A. Sample description is maybe PiO2. Okay, so this is the most important part. So you really need to put in the scan range because your peak position, if let's say you have titanium oxide, you need to perform to search in Google or any literature. For example, your titanium oxide, the scan range is from which degree to let's say the peak. For example, that I show you just now. Okay, the titanium maybe is around 28 until 80. So you need to choose the correct range. If not, okay, if not, if let's say normal run, maybe we can run up to 10 to 80. So some of them, your peak available at 5 degrees. So you will not observe in the result. So that's why in the first place, we really required you to put in the details on the scan range. If let's say it's the first time you run the SRD, you didn't know what is the range, you can always search. You know what are the compound available in your material, so you just search. So basically the range is similar. It will not differ much. Okay, so the exposure time and the exposure time is not really crucial. So if let's say your percentage of compound is very small, then we need to increase the exposure time per step in order for you to get better intensity. Okay, right? So after that, you need to select cost center, and then you can submit request to researcher. Okay, and then Encik Irwan, once you submit the request, Encik Irwan will generate the quotation, and then you will need to send the quotation to your supervisor, and your supervisor need to request budget utilization from your research. Once approved, so Kyle will receive an email if the your research if your request has been approved in your research. So once it has been approved, Kyle will proceed to assign slot, and you can submit the samples to sample submission room at block P. Okay. All right. So I think there is one question just now.
Two questions je lah. From
Two.
Gamal and Ali Raza.
Okay. All right. Okay. How to calculate the crystallinity? Okay, crystallinity, basically it will be depends. You need to have one peak as a reference, and you need to calculate the intensity. So you need to choose one peak as a reference, and another peak, and then you calculate the ratio, the intensity ratio, and you will know the degree of crystallinity. Okay, so how to choose which peak need to be used? So you need to really consider that the peak is really not um, affected when you vary the parameter. The peak is not affected with the parameter. So that is how you calculate the crystallinity, degree of crystallinity. Okay, and then
From Ali Raza.
Ali Raza, wait,
Yeah. If there is a mineral that is not already defined in the software, then can we use it to know the crystal structure?
If there is a mineral that is not already defined in the software, then can we use it to know the crystal structure? Okay, basically, um, it for SRD is really depends on the database of the software. Okay, if the mineral have the structure is have within the database, then we can know the crystal structure. Okay, for us, our software is using ICSD database, which is not really up to date of database, because we purchase it. We get the database in when we bought the equipment. It is when 2017. So I guess some of especially the new structure, most probably is not available in the database. But there's a one way, is a free database. So I guess it is the updated one. So we call it as COD. But it's a free database. You can always install at the software and try to compare your result with the free COD, free database available in the internet. So but the quality of the database is if we are using COD, we could not really confirm on the quality database, because if ICSD or if we purchase the ICDD, is coming from the trusted apa trusted body, so it will really screen the database. If COD, everyone can dump the database, dump the pattern, and but you need to really carefully select the which one you use to compare to choose as your compound. Okay. 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 Up to how many compounds can we select for the peaks? Do we need to eliminate all peaks? What's the cutoff of picking compounds? How many compounds to? There's no limitation, as long as normally you will be, especially for sample from geoscience group. So basically, you will have many crystals available in your sample, right? And the percentage for each compound is very small. So you can choose like 5 to 10 compounds, okay, to as long as all the peaks, in your result SRD pattern 2 they are identified with the data with the structure from the database. Okay, and then do we need to eliminate all peaks? Why do we need to eliminate the all peaks? Wait, Mariam, I try to open the Mariam. Siapa nama ni Mariam? Yeah. Okay, Mariam, maybe I already allow you to unmute. What do you mean by
I mean, do we need to match all the peaks?
okay. Uh
Because in the
the
one you shown, there are some peaks that
mhm.
are not matched. So do we need to match all or just leave it?
Okay, it depends on your study. If let's say you already found your intention is to see the copper oxide as so for certain compound, and uh, some of the you already managed to get your targeted compound, but still there are peaks not match with all of the compounds. It's okay, but you will have problem with the examiner later on. So maybe the examiner will ask. So because there is unknown compound, unknown peak, right? So you will need difficulty to answer them. So what is the compound is actually belongs to lah. So the best is you need to identify all peaks. But I do understand it's really difficult, especially if your you have several type of compound, and the percentage of each compound is very small, and the intensity of the peak is not really high, and it will take time to identify all the peaks. Okay, all right.
Next
Cut off.
question.
Next question. How do we calculate lattice constant and dislocation density? Lattice constant, you can always find it from the database. Okay, and then okay, for a solid sample, how deep X-ray goes inside the sample? Uh, for this one, maybe Encik Irwan, do you have any idea?
For how deep is actually going to inside the
Mm.
sample?
It depends. It really depends on the
The
density of
sam
the material.
Yeah.
Uh,
Normally, the survey engineer told us it's around micron size, but it depends to the density of the sample, like Wan
mm.
Sheila said.
Okay. Okay. So I guess that's all. So last but not least, so if you have any further question, you can always drop us an email or chat via Microsoft Teams. We are always um, welcome you. And last but not least, okay,
There
you
one
have
question,
another
Sheila.
one? One
Yeah.
question, okay. Tak ada dah. Okay, thank you. Alright. Okay. So, uh, apa yang bagi?
No, from Hafiza. You raise
Hafizah,
some.
Hafizah.
Yeah.
Okay. Okay, Hafizah, you can unmute.
Yeah.
Hello, Assalamualaikum to everyone. Kak Sheila, may I
Yeah.
ask you, can
Uh-huh.
I simplify by if let's say I have several type of powder crystal,
Mm-hmm.
can can I simplify the most crystalline or shining material will will give the output with better output, of result.
better team, better SRD peaks. Do you mean?
Yes, yes,
Yes,
the
yes. If let's
sharpness
say
of.
you have a metallic material like apa solid metal, right?
Yes.
That one will give you better SRD peaks compared to uh, ma- uh, compared to metallic powder that you synthesize by yourself. Let's say you, for example, like copper, for example, like Fe powder. Okay.
uh,
So for the metallic material, it will give better SRD peak. It's because of the arrangement of the arrangement of the unit cell tadi.
and
If let's say in that one is the solid material, the crystal structure is properly aligned, so the peak, it will give constructive peaks, and the intensity peak will be higher compared to powder sample. Uh, it has a similar crystal structure, but the direction will be different. So that's why the peak is getting broader.
okay, and one more thing, from
Mm-hmm.
the XRT output we can get the crystallite size,
Yes.
and also can we get the particle size?
No.
No. And can I simplify also,
Mm.
like crystal size is smaller than particle size. Particle size, it
Yes.
doesn't mean it's not crystal, but it might be crystal in this contact.
The particle size, you mean?
Yes, in
Uh,
the XRD punya contact,
mm.
if we said that particle size, it's some of the made of a few of crystal size.
Yes, that is correct. So, particle size is basically consists of several crystal lah.
So lesser particle.
Including if let's say your sample is semi-crystalline, it has crystalline part, and it also have the amorphous part. So when you measure the particle size from PSAM, TEM, and also the particle size, you will measure the distance comprised of crystal and
Can,
also the amorphous part.
can we say like this? Smaller particle size will give us better peak of SRT.
Smaller particle size, not really, because if you have smaller particle size, okay, like this one, okay.
Okay.
If let's say apa smaller particle size, which means a nano material, it has smaller particle size, right? But in SRD peaks, because of the 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 crystal is actually not really um, properly the arrangements is not in properly direction. Some of the, for example, like this one, some of the crystallite size uh, is at this direction, and this one is at this dia sengit sikit. Yang ni sengit sikit kan. So because of this arrangement, okay, it will not give similar maksudnya diffractive peak yang konstruktif. Maksudnya yang ni mungkin bagi kat sini. Okay, tapi yang ni mungkin uh, apa direction dia peak position dia dekat sini sikit. So that's
Okay.
why we are
Okay.
obtain broader peak untuk
Got,
yang
got it, got
smaller
it.
crystallite size.
And that one in terms of particle size. Let's say I have a smaller crystal size. Which
Mm-hmm.
one better? Smaller crystal size or bigger? Because bigger crystal size, we know that multiple layer of.
For SRD is actually is of course, the big crystallite size will give a better SRD peak.
Okay.
Um, okay, SRD is not really apa? It 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 is developed to get the uh, for proper arrangement of crystal material. So it's really not maybe the latest technology, maybe it have some improvement for the nano material, but that's why no, usually for if your sample is in if nano material, so that's why your peaks, your SRD peak is getting broader compared to your if your sample is in bulk size, bulk material.
And one more thing, Kak Syif tadi ada mention apa tu bilik computer analysis punya untuk XRD kan? Memang ada provide dekat KAL ke?
Ada dekat P0007. So the room
Procedure dia kena request kat Cik Irwan?
no need. You can just come. So the room is actually open from 8 to 5.
Okay.
So you can just come, and if there's no one use the PC, you can always use. No need to book upfront.
Okay, okay.
Okay.
But if you need any guidance or manual or any video how to use the software, you can ask from us lah.
Okay. Got it. That's all. Thank
Okay.
you.
So okay, thank you everyone. We need your assistance to give feedback on this session so that we can improve further in the next session. So I think that's all for now. Thank you everybody and have a good day. Thank you.
Thank you.